Re-entering a building post-fire without proper assessment is perilous. Structural integrity may be compromised, and toxic fumes or residual heat can pose severe health risks. Adhering to safety protocols is essential to mitigate these dangers and ensure a secure environment for recovery operations. Uncontrolled re-entry after a fire presents significant risks, including structural collapse and toxic exposure. Strict protocols are essential to ensure safety and prevent predictable failures. Recognizing these dangers is crucial for effective post-fire recovery and minimizing organizational liability. Evidence from incident investigations and occupational studies consistently shows that out does not mean safe. Structural collapse, toxic exposure, and reignition risks persist during overhaul and debris removal. Institutional protocols emphasize that re-entry should only occur after a documented safety determination by competent authorities. Post-fire environments present multiple hazards. Weakened structures risk sudden collapse, while toxic gases persist, posing respiratory threats. Hidden hotspots may reignite fires, and damaged wiring increases electrical risks. Additionally, moisture fosters rapid mold growth, creating biological hazards. Comprehensive safety assessments are crucial to mitigate these risks effectively. Fire weakens steel, concrete, and timber, compromising structural integrity. Firefighting water adds load, while overhaul vibrations and material removal exacerbate risks. Walls and floors may appear intact, but can be compromised. A National Institute for Occupational Safety and Health case study highlighted a collapse 90 minutes post-dispatch, trapping personnel and injuring an inspector. Modern structure fires release complex toxic gases like carbon monoxide, hydrogen cyanide, volatile organic compounds, acidic gases, polycyclic aromatic hydrocarbons, and metals. Carbon monoxide is an inadequate safety indicator. Multiple contaminants surpass short-term limits during overhaul, and seemingly clean air may harbor hazardous particles. Polycyclic aromatic hydrocarbons persist for weeks, and surface residues can re-emit volatile organic compounds long after extinguishment. Embers hidden in concealed spaces can smolder for hours, posing a rekindling risk. Thermal imaging cameras are crucial for detecting fires in walls, ceilings, and floors. Rekindling can occur even after apparent extinguishment, producing substantial toxic emissions. Implementing thermal imaging and maintaining a fire watch for the first 24 hours post-extinguishment are essential controls. Electrical hazards arise from soot's conductivity and heat-degrading insulation compounded by moisture. National Electrical Manufacturers Association warns against re-energizing without expert evaluation. Gas systems must remain off until inspected. A gas odor demands immediate evacuation and emergency contact. Only qualified personnel should restore fuel systems to ensure safety. Water damage significantly increases biological hazards, primarily through mold growth. Key sources include sprinkler activation, hose streams, and broken pipes. It's crucial to dry wet materials within 24-48 hours to prevent mold. Materials that remain wet must be discarded. Additional risks involve contaminated water, sewage disruption, disease vectors, and potential drinking water contamination. Understanding hazard timelines is crucial for effective risk management. Biological hazards, like mold, can develop rapidly within 24 to 48 hours post-water damage. Persistent hazards, such as contaminated water, require ongoing monitoring. Timely intervention is key to mitigating these risks and ensuring safety. A structured approach to hazard timelines aids in preventing long-term damage and health issues. A defensible staged re-entry model ensures safe re-entry by distinguishing between actions like retrieving belongings and full occupancy. This approach minimizes harm and liability by preventing category errors, treating re-entry as a series of informed decisions rather than a singular event. Authority release mandates fire marshal clearance. Utilities inspection involves thorough checks of electrical and gas systems. Structural safety requires stability assessments before re-entry. Contamination evaluation includes testing for toxic residues, implementing hygiene controls, surface cleaning, moisture control, and systems testing to ensure safety. Multi-parameter monitoring is crucial for identifying hazardous atmospheres, ensuring comprehensive safety. Personal protective equipment is indispensable for responders in dangerous zones. Carbon monoxide monitoring alone is insufficient. A thorough assessment is necessary. Role-based equipment must be tailored to meet specific operational requirements, enhancing safety and efficiency in hazardous environments. Re-entry authorization requires a written release from the incident commander or fire marshal. Structural assessments must confirm stability, and fire control measures should address hotspots with thermal imaging. Utilities must be isolated by qualified personnel. Document multi-parameter monitoring plans, contamination remediation, and moisture management. Ensure thorough documentation and clear communication with occupants, outlining a staged timeline. Invisible dangers like structural collapse, toxic residues, and electrical hazards persist post-fire. Supervised pathways are crucial to prevent unauthorized access. Re-entry involves staged milestones with clear criteria, ensuring safety and evidence preservation. Unauthorized entry can compromise investigations and safety protocols. Even after a fire is extinguished, dangers remain. Hazards like structural instability and toxic residues persist. Always wait for official clearance before re-entering. Adhering to protocols and preventative measures is crucial for safety, property protection, and reducing liability. Comprehensive documentation and assessment are essential in the re-entry process.